Okay, back we are. Suppose that I have a lid to a hot drink cup. So I have a cup, and we'll call that, the diameter of the cup is C, and we have a lid, we'll say the diameter of the lid is L. So it'd be really nice if the lid was just a little bit bigger than the cup. Have you ever been in McDonald's or somewhere where the lid and the cup are almost identical in size and they just won't fit? Well, we would like it to fit. So we are hoping that the lid, let's say the difference, lid minus cup, we are hoping that that difference is between 0 and, we don't want it to be 0. If the difference is 0, they're identical and they won't fit on one another. So we're hoping that the difference is going to be bigger than 0 but less than 0.06 inches. If that's right, it'll fit snug and it won't be too big, so that it's not like it's like having no lid at all when it's too big. So that's what we're looking for. And it turns out when you make cups that in the factory, they are supposed to all be the exact same measurement, but they are not. They follow a normal curve where, so I'll say normal, and I'm going to say the mean of the cup is 3.96 and the standard deviation of the cup is 0.01. And then when we go over to the lid factory, that is also a normal curve and it goes up. It starts at the mean of 3.96 and its standard deviation is 0.02. So the question is, what is the probability of finding this happen? Because this is when the lid and the cup fit nicely. So what's the probability of that given the cups have this normality and the lids have this one? Alright, so to do that, we have to look at lid minus cup. So lid minus cup is going to be a difference of two random variables. But if we had the mean and the standard deviation of these differences, we know from our discussion that when we combine two normal curves, we get a normal curve that works for addition and for subtraction. So we know that this difference is a normal. So L minus C is a normal curve as well. So what is, I need to know the standard deviation and the mean of this difference, which I'll call D. Well, we learned that to get the mean, we're just going to subtract these two. So we're going to do lid minus cup. So that's the small number, 0.02. So the mean of the difference is 0.02. And what is the standard deviation of the difference? So we kind of come up with an example anyway. Standard deviation, I'll use the same symbol. Standard deviation is we're going to take the standard deviation of the first, 0.02, and square it because that's the variance, and the standard deviation of the second and square it because that's the variance. And what are we going to do with these two when it's L minus C? We're going to add them. That's what's the point of most of our class today. So that's good. We kind of ended up with an example anyway in the middle of that. So when I calculated that, I got 0.0224. Alright, so now I have a normal curve with the mean of 0.02 and the standard deviation of 0.0224. So I'll write that normal curve, standard, the mean or expected value 0.02 and 0.0224 is the standard deviation. So from that information, what's the probability of the difference being between 0 and 0.06? So we've been practicing those. So pull out your chart A and find your z-score. You're going to do a z-score for 0 minus the mean divided by the standard deviation. and you're going to do the z-score for 0.06 minus the mean divided by the standard deviation. From those two z-scores, you'll go into the body of the chart and get two areas, and you will subtract this one from this one. So I went ahead and did that, so you do it. Turn this off and then turn it on and see if you get the same thing I did. Alright, if you're back, you're done. I got a z-score of 0.89 from the 0, and I got a z-score of 1.79 from the from the 0.06. So now I went to the chart, and my negative 0.89 z-score gave me a 0.9633, and from 1.79 I got a 0.1867. So I'm going to subtract those, and when I did, I got, when I subtracted these two, I got 0.77, I think I'm running out of space, 0.7766. Alright, if you can't see it, you can hear it, 0.7766. So that's about 78% of the time the lid and the cup will fit nicely. So if you were selling cups to manufacturers of drinks, I think you would like that to be a little higher. That means what, 22, how much? 22% of my cups are going to spill on the people. So, alright, well I'll have to bring in some cups and lids and we'll test ours with hot drinks and see if they confirm that low percentage or not. Alright, till that moment, that's all for today. Your assignment is going to be reading, page, let's see if I have it written down here. I do not have it written down, of course I don't. Alright, well I want you to read to the end of this section from where you are. Not, I think that's the end of section 6.2. So from wherever we stopped our reading, read to the end of section 6.2. And the assignment, the numbers that you're going to do, I do have those, are number 52, 56, 61, 65, and AP 13. Alright, hopefully we'll finish the AP from the last chapter before we take the test on this chapter. We still have a ways to go. We have another whole section to go. Alright, so there we go. That's it for today. Hopefully I have interrupted and I'm here listening to this with you and have good stories to tell you from the courthouse. Alright, that's it. Over and out.